welcome again to King's Bioproduction Academy. Today, we're going to discuss about the enzymes. And on these enzymes, we're going to discuss about where they are produced and where they're being used from. That is enzymes in human beings. Let's start about from the mouth. We are discussing enzyme in mouth. And the enzyme here, we are speaking about which enzyme? Saliva. The end of production. Let's start with the saliva. Saliva enzymes. Where is this enzyme produced? It's produced or secreted by the salivary gland. The salivary gland is the one that do what? Secretes this form of enzyme. So we are speaking about what? Salivary enzymes. Where is it secreted? It's secreted from salivary gland. We are saying not produced an area of secretion. We are speaking about what? Area of secretion. And we are speaking about the area of secretion in which we are speaking about salivary gland. So salivary gland secretes salivary amylase. What will be the role of the salivary amylase? So we are speaking about the role or its function. What is the function for the salivary amylase? And the role of the salivary amylase is to break down. We are speaking about what? Breaks down starch to maltose, starch to maltose. And where specific in the salivary glands are these things secreted from? And where they're secreted from will be parotid gland. We have sublingual gland, and number 3, submandibular gland. Those are the 3 glands that will do it, that will secrete these enzymes that we're speaking about, the salivary amylase. So we are speaking about salivary gland, and the salivary gland will be having these sections of secretion: parotid gland, submandibular gland, and the sublingual gland. That is where we secrete these things. Then we have number 2, which is the lingual lipase. We have number 2, lingual lipase. And this lingual lipase, it will be doing what? The lingual lipase. Where will be the lingual lipase being secreted from? It's secreted by something called von. We are speaking about what? Von Eppner's gland. Eppner's gland. So we are speaking about what? Von Eppner's gland. And what will be? It will be located below the tongue. It's located in the tongue. And it will be breaking down fats into triglycerides. We are saying here what? Breaks. That is the fats. Triglycerides. Triglycerides into fatty acids. To fatty what? Acids. But this one is not the main area where we break the fats. Where are the fats broken from? Fats will be broken down by which area? It will be broken down by pancreatic lipase at the duodenum. But this is where we still break the fats in the mouth. Fats we say can be broken down in the mouth by lingual. We are speaking by lingual. It's lingual lipase. Lingual what? Lipase. That is in the mouth. We are done in the mouth. Let's now discuss in the stomach. The second section is where? The stomach. And what will be? But before that, let's check first other non-essential components in the mouth. Other non-essential components. Other what? non-essential, which are not enzymes. In the mouth. And those ones are what? Mucus, lysosome. We are saying number one, mucus, lysozyme. We are speaking about what? Mucus, lysozyme, and we have immunoglobulin. Immunoglobulin. Number three, we have what? Immunoglobulin. And when you speak about mucus, mucus will be secreted. What will be the role? To lubricate. It lubricates that food in the mouth for ease swallowing. We are speaking about what? It will be lubricating the food in the mouth for easy swallowing. For easy what? Swallowing. Then number two, it will be having, that is the lysosome, it will be having antimicrobial enzymes. How what? So we are speaking about for the lysosome. This one has what? Antimicrobial component. And this one is to break any material that may be present in the food. That is bacteria. This one breaks what? Bacteria in the food. Breaks what? Bacteria in the food. That is the lysosome. The lysosome will be doing that. Then the immunoglobulin will play a role of what? Defense. This one plays a role of what? Defense. Just those are amino acids, right? So it will just play a role of what? Defense. Defense in the oral what? Cavity. So we're saying what? We have in the mouth. We are discussing about the enzymes, and the enzyme which will be secreted in the mouth will be salivary amylase. Where does we secrete from? Salivary gland. Which are those areas of the salivary glands? Parotid gland, sublingual gland, submandibular gland. And we are saying those ones, these salivary amylase will break this type and detect in your food to maltose. Then the second, it is in your diet you have lipids. The lipids will be broken down by lipids. And where are the lipids produced? Von Ebner's gland. The von Ebner's gland. The Ebner's gland will secrete the lingual. The lingual lipids which will break triglycerides to fatty acids. Then number three, we are saying we have other components which are not enzymes but play a role in digestion. And we are saying we have mucus. How does it play a role in digestion? Lubricating our food for its swallowing. Then we have the lysozyme. That is the lysozyme. And this one we are speaking about, it has antimicrobial components. And that antimicrobial components is to do what? To break any bacteria that may be present in the food. Then we have the immunoglobulin, and we are saying that will play a role of defense in the oral cavity. Let's go to number two. Let's go to number two, which is now in the stomach. We are discussing where? Stomach. Let's discuss still about the enzymes in the stomach, area of the secretion, where are they produced, and again, the non-enzymatic. Those are enzymatic enzymes that will help in the digestion still in the stomach. Number one, in the stomach, we are enzyme. What? We have the enzyme in the stomach, which is the area first of the secretion is the gastric gland. Area of secretion of stomach, we have the gastric gland. We have the enzyme pepsin. We have the enzyme renin. We have what? Enzyme renin. We have the enzyme pepsin, and we have the gastric lipase. So when you speak about pepsin, number one, we are speaking about in the stomach lining, we have the gastric gland. This gastric gland will secrete enzyme number one, which is what? Pepsin. We are speaking about what? Pepsin. This pepsin is secreted by the gastric gland, but it's not secreted as pepsin. It's secreted in its inactive form, that is pepsinogen. We are speaking about what? This one is an active form. This one is an active form, but inactive form is what? Pepsin. pepsinogen. And this pepsinogen will be activated by an enzyme called, not enzyme, but by hydrochloric acid to pepsin. What will be the role of the pepsin? And where are these pepsin produced to be specific? We're speaking about the area of secretion is gastric gland, but which area is specific of gastric gland? That is the chief cells. In the gastric gland, we're speaking about what? The chief cells are the ones producing pepsin. And what will be the role of the pepsin? It will be breaking down. We're speaking about the role of pepsin. Breaks down proteins. It breaks down proteins. Proteins to what? Peptides. Proteins to what? Peptides. Proteins to peptides. It will break down proteins to peptides. And again, this one is by hydrolyzing the peptide bond. We're saying by doing what? By hydrolyzing. Hydrolyzing is breaking. By hydrolyzing peptide bond. So students, you should understand these ones. And we are speaking about what? We have in the stomach, the gastric gland. But inside the gastric gland, we have some chief cells. And those chief cells are the ones that will be secreting pepsin. And now we're saying pepsin is not secreted as pepsin. It will be secreted as pepsinogen by what? Chief cells. And those pepsinogen again will be activated by hydrochloric acid, which will be produced in the stomach. It will be activated with pepsin. This pepsin will break down the proteins in your diet, that is in the stomach, to peptides, And we are saying it's done by hydrolyzing peptide bond. That is break down the peptide bond. We get peptide, right? Then we have number 2, renin. We have number 2. This number 1. Number 2, we have renin. Renin is double N. Still, it will be produced by the chief cells. We are speaking about what? Still produced by what? Chief cells. So the gastric gland, those chief cells in the gastric gland secretes renin, and this role will coagulate. It coagulates milk protein from casein to caseinogen. And this one happens in infants. We are saying it happens in infants. That is young ones. So the young ones, they depend, especially children. Their main diet is milk from their mothers. And this milk cannot be broken down by pepsin. It has to be coagulated by, we are saying, all the chief cells will be secreting an enzyme called renin. So this renin will be broken down to caseinogen. We are saying we have the coagulation of this milk protein from casein to caseinogen. This caseinogen now will be the one that will be broken down to peptide. It will be broken down to peptides by what? By pepsin. Hope you understand now the procedure. We are speaking about the infants. Pepsin cannot function directly, but indirectly. But the one that plays the role is the renin, breaking the milk protein casein to caseinogen. This caseinogen is coagulated and broken down by pepsin to peptides. That is number 2. Number 3, we have gastric lipase. We have gastric lipase. Gastric what? Lipase. That one again will be done by the chief cells. It will be done by the what? Chief cells. And this role now will just break the role like number 1 that we've spoken about in the mouth. That is broken down what? Triglycerides into fatty acids. Breaks down triglycerides into fatty acids. But we are saying this one is not major breakdown of lipids. Lipids is not majorly broken down in the mouth and in the stomach, but the main is at the duodenum. So you should just know that we still have some breakdown of lipids in the mouth and some breakdown in the mouth, in the stomach, sorry. And this in the stomach is speaking about gastric lipase. Gastric what? Lipase. Gastric lipase. Let's go to the non-enzymatic but essential. Those which are non-enzymatic but essential. Enzymatic but essential. Which are those ones? We have hydrochloric acid. Hydrochloric what? Acid. And this hydrochloric acid are produced by peptic cells. They are produced by what? Peptic cells. They are produced by not peptic cells, sorry, the peptic, parietal. Parietal cells. They are produced by parietal cells. And this one will have some three functions. It will kill any microorganism or bacteria, any bacteria. Let's just use bacteria. Any bacteria in food. That is the first. Number two, activates inactive form of pepsinogen to pepsin. And again, it will activate the what? Caseinogen. Casein to caseinogen. Then number three, provide acidic medium. Provide acidic medium. So what are we speaking here? We are speaking about the stomach. We have some enzyme. Areas of secretion is the gastric gland. On the gastric gland, we have some cells. And the first cell, major cells, are the chief cells, producing pepsin. And this pepsin have to be activated from the inactive form, pepsinogen to pepsin. This pepsin will break down the proteins to peptides. Breaks down proteins to peptides. How does it happen? By analyzing the peptide bond. Number two, the renin. We say that is in infants. This one metal will be what? Infants. And how will it happen? It coagulates the big protein from caseinogen to casein. And this casein will be broken down by pepsin to peptides. Number three, we have the gastric lipase. It's not the main, but we're saying the main breakdown of lipids will be the duodenum. It will be broken down by the chief cells and the secondary gastric lipase, which will break down triglycerides into the fatty acids. Then next we have the non-enzymatic but essential, and that will be in the stomach, will be hydrochloric acid. In the stomach we secrete some gastric gland secretes three things. Pancreatic, it's the enzyme. That's pancreatic lipase and urinary. Number two, mucus, which will coat the stomach valves to prevent it from being corroded and even digested by the protein digested inside. And number three will be hydrochloric acid. This will be secreted by some cells called parietal cells. So hydrochloric acid is secreted by parietal cells. That was a basic question. Then it will kill any bacteria in the food. That's what hydrochloric acid role. Activation of the inactive form of enzyme. That is pepsin to pepsinogen to pepsin. Prorenin to renin. You're speaking about prorenin to renin. Then the last one, providing an acidic medium. Let's go to the small intestines. Small intestines. Now the small intestines, it will be divided into two sections. That is number one, duodenum, and number two, jejunum. The jejunum. The jejunum, or you can call it, we can have the length, that is the ileum, which is a bit elongated. So we are speaking about number three, we are small intestines. And I've said that the small intestines, I'll start with the duodenum. Let's start with what? Duodenum. And on this duodenum, what are we supposed to discuss about the duodenum? On the duodenum, let's discuss about the enzyme from pancreas. Enzymes from where? From pancreas. What happens in this point? Those enzymes secreted, these enzymes are secreted from they are released to small intestine via pancreatic duct. We are saying they will be released to what? Pancreatic duct. So we are saying the area of secretion here, area of secretion will be pancreas. and they will release through pancreatic duct to duodenum. Is that clear? So it's the pancreas. We speak about our pancreas being gland, it's a gland. So these are glands. These glands secrete those pancreatic enzymes. And which are these pancreatic enzymes? Number one, we have pancreatic amylase. Number one, we have pancreatic amylase. And this pancreatic amylase role will be, what will be the role of the pancreatic amylase? It will breaks down those proteins. Breaks down proteins to amino acids. Not amino acids, but to peptides. To what? Peptides. That is number one. To peptides, number one. Number two, we have pancreatic. This one is pancreatic lipase. This one is trypsin. I'm very sorry. I'm saying we have trypsin, number one, breaking down proteins to peptides. Number two, pancreatic amylase. Amylase break down remaining starch to maltose. Number three, you have pancreatic lipase. Will break down fatty acids. Fats to fatty acids and glycerols. Those are the three main that we are speaking about. Then still we have the nucleases. And these nucleases are which one? These are the RNAs and the DNAs. We are speaking about RNAs and DNAs. So this one breaks down what? They will break down those nucleic acids. So we are saying breaks down what? Nucleic acids. That happens in the duodenum. That is where? In the duodenum. What about the ileum? Or you speak about the duodenum. That is in the duodenum. In the small intestines, we speak about digestion and completing the digestion process. That is conversion. Let's now in the ileum we speak about conversions. We speak about what? Conversion. So in the ileum we are speaking about conversions. So what are we converting? Like number one, we have enzyme, maltase enzyme. This maltase enzyme breaks maltose to glucose to sucrase, which will be sucrose to glucose plus fructose. Number three, lactase will be lactose to glucose and galactose. That is it. Then we have the remaining peptidase. Peptides. So we speak about what? Peptides. Two amino acids. Then we have lipase as the fifth. Two fatty acids. So it's lipids. Two fatty acids, and blood. So thank you for your time. You can like it and also subscribe so that you can learn more from this biology. This one, I'm a biology teacher by profession. I teach biology. I love this subject. It's a good lively subject whereby you can understand more about yourself and even to the nature and even how our body can conserve and